Hello, so it's great that you have finished the week one and week two. So yeah, week one and week two is only the introduction of the introduction. So it's only a first try of some AI application. Don't worry, we will repeat, and then repeat, do more and more applications about AI and data analytics in the health science. So it's just a first try. So whatever you success or not. So yeah, it's your first time, so don't worry. And then here we will move to our lesson two. So yeah, here we are. So it's just like the brainwashing, and then we will go deep, repeat and repeat and repeat in our course. So here we will repeat what is ML, machine learning. Okay, ML is machine learning model. So machine learning model is a representation of the reality that the AI is not going to ask you to input the rules if then else, no more if then else. The only thing you need is prepare the data set. Okay, prepare the training. So you have lots of the input data, you have lots of the expected output, and then the machine learning algorithm, the machine learning model, they will learn the relationship of the input and the expected output one by one. So we'll learn, at least in this course, we'll learn one of the algorithm. The next one of the algorithm that how we can proceed this kind of training. So how the relationship can learn one by one, one by one, one by one. In fact, one of the algorithms that we are going to use is called neural network. And the neural network is going to simulate the linear equation. Linear equation is one of the algorithm or one of the formula that you have learned in your, I guess it should be middle school, Form 1 to Form 3, something like that. So don't worry, the mathematics is really easy to understand at the very beginning level. So brainwashing, put a star on this line. So maybe in your quiz or later on, this line will be repeat, repeat, and repeat. So this is one of the fundamental concepts to classify the machine learning, to let you know what is the task that you can perform in the machine learning. And then most likely, if you want to communicate with the other, so that is how you can explain what is the machine learning task that you are going to do. So here, machine learning can be classified in supervised and unsupervised learning. Supervised learning, that means you have the sample data and then you have the expected result. That means you have lots of the dog photos and then lots of the dog photo is tagged or is renamed, is classified as dog photo, dot, etc. And then maybe you have another set of cat photo and then all the cat photo will be classified as cat. So this is supervised learning. Supervised learning can be classified into classification and regression problem. Classification, so somehow um, that means some cats, dogs, so they are classification. That means they do not have a linear relationship. Unlike your age, unlike your height, unlike your weight, etc. So it's a numeric linear equation. So age, you have 0, 1, 2, 3, 4, 5, 6, until 100, something like that. And then for your height, so you have the 30 something to 150, 160, 170, etc., etc. So those are numeric. Numeric is regressions, is continuous data. But test, DOS, dolphin, Peter, or you, we do not have a linear equation. We do not have a linear numeric relationship to connect between you and me, cats and dog, etc. So they are discrete data. They are discrete data. And we are saying this one is classifications. And of course, you have, besides supervised learning, you have also unsupervised learning. Unsupervised learning, that means you only have the sample data without any expected result. For example, you're going to do the customing or you're going to do the dimension deduction. But this part will not touch in this 2 weeks, in this part of the lecture. So we will only touch one thing, supervised learning. Okay. Yeah, and this week we are going to touch supervised learning. Supervised learning, as I have mentioned before, so we collect lots of the photo. That is the data. That is the data. Some of the photo may be dots. Some of the photo may be cats, whatever. All these kind of photos, you need to give them labels. You need to give them the correct answer of your image. So supervised learning is a type of machine learning that we use the labeled data. So with our result, we do not know this kind of image fall into which category or which class. So we need the label. And the goal of the learning is learn the relationship or all the image feature. So the image feature can guess, or we say they predict the labels. So you put lots of the image photo to them, and then the algorithm study about the feature, study about the image distribution. We'll discuss later again. And then they will return the label that you have tapped. Okay. So somehow when you have lots of the photo, and then the algorithm is going to remember all the photos. So if you have the sample data, put it into again, most likely they can remember the photo. And then they will understand, formulate the feature, formulate the key feature of cats, for example, for the dogs, for example, they have a bigger ears, and then, for example, the cats, they have the smaller but triangle ear, etc., etc. So they try to formulate the relationship, the feature of the photo, and finally they can predict, hey, when you have the new photo or when you have the new dot, another angle, etc., they can answer, hey, maybe I say I'm a dot, okay? When you input my photo and then label, hey, Peter is a dot, Peter is a dot. So when you take another photo of Peter, input into the system, they understand the feature of the Peter, and then they will return, hey, Peter is a dot, okay? So if we want to classify them into a better mathematical presentation is we have a formula, okay? So, or we say we have a function. And then function, we have the input feature x1, x2, x3, blah, 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 etc. So those are the input informations. And then throughout the machine learning algorithm, so we want to get the result y. So y will be the expected result. So we use the attributes of x1, x2, x3, etc. to predict a categorical variables y, and then the equation will be like that. So x and y can be say that it will be two variables, x, x1, x2, x3. So they are the predictor variables. So they are the independent variables. Independent variable, that means that you will not affect by the result. In another way, so y, we call it the target variables. And then the target variables, they are the dependence variable because the value of y will be changed by the x1, x2, x3. So that's why we say it dependence variable. x1, 2, 3, we say it's independent variables. So here, cats and dogs we will touch later because it's a little bit difficult to say the result of the image. So we use another example, happy and unhappy. So your university life, happy and unhappy, they are the dependent variables. It will affect by, for example, number of fans, maybe the most important things, maybe your GPA. And we also collect some of your demographic data. For example, your gender, or for example, your age, etc., etc. So you can collect lots of these kind of variables to predict or to classify where you are happy and unhappy. This here is the classification because happy and unhappy, we do not have a numeric information or numeric linear equation, linear relationship between both of them. So we just say happy, unhappy, and those are the classification problem. So beside the psychosocial problem that we have discussed, happy and unhappy, perhaps we can go to a little bit more a little bit more serious. Okay, for example, the breast cancer prediction. So you can collect lots of the target variable, for example, the age, and also the smoker or not, etc., etc. So those are the independent variables, and then you can use the target label. That means they have cancer, with cancer or without cancer. So those are the target labels. So you can see that this one is not so serious, but we use lots of these kinds of independent variables input data to predict one output, cancer or not. So in many situations, so this kind of the target variables will be counted by a few hundreds or will be counted by a few thousands. So the output variables, that means the dependent variable. So they can be here, primary. That means previous example, cancer or not cancer, with cancer or without cancer. So they are primary, yes, no, true, false. So it's primary. Or it can be multiple cards. For example, previously we can input lots of the photo of cats, dogs, dolphin, shark, Peter, you, etc., etc. So it can be a multiple classification. Of course, primary will be easier because it's only 1 or 0. It's a pretty easy classification AI problem. Multiple class will be a little bit more and more difficult. So, for example, there is one very well-known database. It's called RS database. So they have collected 50 files from 3 different kinds of species. So they have I'm sorry, I have no idea with the file name. File A, file B, and file C. So that is my representation. So they have 50 photos of file A, file B, and file C. And this file A, B, C, and this 50 photos of flower ABC. So they will have the species flower A, flower B, flower C, X to Y value. And then they have the input value X1, X2, X3, X4. So they record different parts of the flower, the length and then width. So they want to predict what is the species of the flower ABC. So this one is one of the good example in previous OH one. I would say that 20 years ago, and then to predict, or I would say that to measure the accuracy of the machine learning algorithm. So this one is one of the useful data set. So they try to find out different parts of the flower and then measure the dimension of different parts of the flower, and then to predict whether they are flower A, B, or C. So that one is interesting. But honestly, so the previous data set, our data set is all are recorded. So all the data, they are well prepared. So somehow we want our AI algorithm that can be used in the real world, because in real world, every day we have the new data, we have the new photo, we have the new unknown data, unknown object that we want to classify. So we want to evaluate the classification, the accuracy of this kind of data set. So do we have a better representation or better matrix to represent the accuracy of the AI algorithm? And that is our questions. So we have to find a method to measure the accuracy of the machine learning algorithm, because after you have training, after you say that, hey, yeah, I have a machine learning model, but I don't know how to represent them or how to say this model is good or not, then the other people, they will not trust your model. So we have find a method to measure the accuracy of the machine learning model. We call it positive or negative class. So what is the meaning of positive and negative class? So yeah, I guess all of us, we have the experience about the COVID-19, right? So the COVID-19 is easy to understand the positive and then the negative class. So this one is our predictor, is similar to our machine learning algorithm. So we have the exact, we have the true value. So we have the true, maybe positive COVID-19 or negative COVID-19. I may be positive, okay, but somehow the tester here the predictor AI algorithm may say that I may be negative or I may be positive. If I am positive, and then the predictor say that I am also positive, that means this one is correct. So we call it true positive here, true positive. If I am negative, and then the predict result is also negative, that means it's true again. So here we call it true negative. And this one, true negative, true positive, will be the true value that we think that the result is correct. And then if all the value fall into the true negative and then true positive, that means they have great ability to find out the true positive and then true negative. That means this prediction is 100% correct. It's perfect. But honestly, for all the AI algorithm or this kind of testing, they are not so good, right? So they have the fail rate. They have the fail rate. So if I'm positive and then the results say that I'm negative, this one is called false negative. If I'm negative and then the results say that I'm positive, so this one is called false positive. So both of them affect the accuracy. Both of them are not good. Especially in healthcare, we care about the false negative because it's really important, right? So if I'm positive, but you cannot find out, you say I am negative, and this one, I trust your result, and then I go outside, for example, COVID-19, the COVID will be spread out. So this one, we care, we really care. So yeah, compare with the I'm negative, and then you say I'm positive. So honestly, I will check the another AI algorithm or check another test again. So honestly, we will check 2 or 3 times. But if you say that I'm negative, most likely I will trust you and I will not check again. So this one is really, really important. Okay. So we use another example to explain this one. So this one is called confusion matrix. And this table, you can put a star here. You can put a star to remember this one. So definitely in your assignment and also in your in-class exercise, face-to-face exercise, quiz, etc., we will have this kind of manipulations, or we will have this kind of testing to test whether you understand the machine learning model or AI model. So suppose that we have a handwriting of digital five, and then we want to see the AI algorithm can recognize or classify the 5 is correct or not. So we have here, can you see that there are different handwriting? There are lots of handwriting of 5. Okay. So here we have 1, 2, 3, 3, 5. This 1, 2, 3, they are by the AI algorithm, they are true. They are true 5, and then AI algorithm say that they are also the true 5. So this one is true positive, true positive. And then in this matrix, so we have 3, and then we have 3 positive here. So somehow you can write down 3 over there. Okay, 3 over there. And then here we have 8, we have 7, 2, 3, 9, etc. So those digits, they are not 5. They are negative. And then the AI predict they are also negative. So in this result, somehow that we can say that for the negative, we have 5 here, we have 5 here. And then here, this one and this one, from our common sense, they are 5, right? But somehow the AI algorithm cannot predict they are true 5 value. So somehow we have 2 false negative here. And here, this one is negative, but our AI think that this one is 5. So we have 1 false positive here. So from this result, from the accuracy of the AI, it can be presented in a convolutional matrix, just like this one. So how to calculate the accuracy? So after we have the table, and then after you have fill in the numbers, and then the table can be extended. So there are different kind of the variables to, I would say, different kind of terms to explain the performance or accuracy of the machine learning model. So it's easy to understand in case you can classify into horizontal and vertical way. We just care the true negative and true positive. That means the true case. The accuracy only care about the true case, okay, correct case. So somehow we have the equations, and then for this one we have the true negative, and then the true negative will be divided by the sum of all the negative. Okay, so you can say this one is horizontal, and then the base will be these two terms. Okay, the base will be these two terms. But somehow the factor that we care, because it's accuracy, we only care the true value, the true value. So another line is similar to that here. So we sum up the two value here, the two value here, and then we only care about the true positive. Okay, so we have another sensitivity value to represent this case. Similarly, if you are looking at vertical part, so we sum up these two value, So false positive plus the true positive. But here we only care about the true. Okay, so we only care about the true path. Similar to this one, we only care about the true path. Okay, true path. And then the base will be sum of the term of the vertical path. So we have this kind of calculation, negative predictive values. But the most important thing we say is the accuracy. The accuracy is calculate all the summarized terms, summarize correct terms, and then all the summarized terms together. So we sum up all the previous testing data. So previous testing data should be 11. Yeah, 11. And then the upper part will be the correct case. Again, in this kind of matrix, it's called, we care about accuracy, so we care only about the correct case. And somehow we have also two terms. One is called type 1 error, and other is called type 2 error. Type 1 error is, so the exact value, they are negative, but here we say is positive, so it's false positive, false positive. Another one will be exact, it will be positive, and then somehow the value will be negative, and then we say it type 2 error, false negative. So try your best to remember this line. So I have removed all the information for you, especially about the accuracy. Accuracy is pretty important. So accuracy is all the true value over all the testing case. So always remember this equation, and then I can put a star inside this equation. This slide try to summarize all the accuracy, all the calculation, all the things you have to understand in the quiz. Put a star on this line. And then if you, for example, the previous flower data set, right? So we have 50 image of the flower, flower A, flower B, flower C. And somehow today machine learning algorithm is really brilliant. So if you keep all these 50 image into your algorithm, and then you use this 50 image to test, to calculate the accuracy of your model. So definitely, the machine learning model, they can remember all the feature of this 50 image, and then you can get 100% correct, and then zero fail. So that is the case of the situation of current machine learning model. So most likely, if we want to test the data of the real case, so all the data we have collect, we will split it into two parts. The first one, we call it here, is the training data set, the upper one. And then another one will be testing data set. So we will put the training data set to the machine learning model, and then let the machine learning model, training model, to learn this 80% of the training data set. Then we'll use this 20% of the testing data set to calculate the confusion matrix or calculate the accuracy of our system to see whether our system is good or not. So most likely we will divide our original data set that we have collected into two parts. The first one will be we will put the XT%, for example, in our previous case, 50 file photo, right? So we will use 40 of the photo to do the training, and then put it into different algorithm. For example, you put it into KNN, or you later in our course, we'll put it into a Google teacher machine, and then we'll get the model, we'll get the trained model for the prediction. Then we'll use the 10 image, 20%, right? 10 image to do the confusion matrix to test whether the machine learning algorithm is good enough. And then we calculate the accuracy again. So most likely we can say that there are two, they have two accuracy. One is the training error accuracy. Another is the testing error. Training error is say that how the model can remember all the things very well. Testing error is somehow is how the model can be applied into new data set, apply into new world to see whether this model can be generalized or not. So to summarize our thinking, and then you have to understand the original data set that we have collected usually will be divided into two parts. One is the testing, another is training. Training is 80% put into a model. Testing is another 20% that to test your data whether it's good or not. So yeah, golden rules in machine learning: never use the testing data for your training. So don't mix this up. So we try to spread it into two parts, and then return the training error. So how good the model can memorize the previous case. Another is the testing error, whether the model they can apply into a new world, new data set. So ML, machine learning, is all about experiment. It's all about how you collect the data, put into the algorithm, analyze the accuracy, and then think this machine learning algorithm or this data set is good or not. Of course, most likely you cannot. I think that maybe you are good enough, but most likely the machine learning algorithm is designed by the data scientist or designed by some math expert. But but I cannot say that you cannot do anything. In fact, a primary school student, they can try to collect different kind of data, put into different kind of algorithm, evaluate their accuracy, and then find the best model or best technical solution, machine learning solution that they can use. So that is totally an experiment. If you are not a data scientist, you can still use the machine learning. It's an experiment, how you collect the data, how you analyze the data, how you have a choose your data. All are the machine learning, all are the experiment. So we will learn more and more separations of the data to achieve a better generalized machine learning or algorithm, or we say data set for your real case. Because if you say that 80-20, right? 80 is the training data set and 20 is the testing data set. So still a lot of data they go to the training, right? So still lots of data they will memorize by the machine learning algorithm. So some of the experts say that 80-20 may not be good. We say that 60-20-20. We only use 60% of our data set to do the training data, and then 20 to do the validation, and then another 20 to do the testing data set. So it really depends on your choice, whether you have collect lots of the data, and then this lots of the data can fulfill most of the real case. So you use the H20, or you just want to collect not so many limit data, and then this limit data can be applied into the real world. So those are two different approach. Both of them, they have the pros and cons, and we really depends on real case. So how to find the best solutions? Honestly, in your previous slide, we have discussed collect, select the algorithm, do the experiment. That means do the accuracy calculation. So that is the cycle of machine learning, ML process. And some of the data scientists, they think that 80, 20, 60, 20, 20 is not enough. So they want to have more and more experiment testing so that they can make sure that they can ensure that the machine learning model is good enough and then is suitable for all the case is really generalized. So they have another concept called cost validation. Cost validation means that the 80-20, 80-20, 80-20, we do it many, 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 many once. So most likely, if we say that if you want to process the 80-20, so at least we will have 5, or most likely we will have 20 from 5 or 20. It really depends on how many computation power or how many times you want to spend on this kind of experiment. So what is going on cost validation? For example, this one is 1, 2, 3, 4, 5, right? 5-fold cost validation. 5-fold cost validation means that I do 5 rounds of accuracy, one first one, second one, third one, fourth, and fifth one, 5-1. So in each one, so we have the 80 and 20 again. So we split the data and then into 5 parts. The first one, we use the first part, it's the testing data set. And then remaining part, it's the training data set. And then we put all the training data set into our machine learning model, calculate the accuracy. Similar things, we have the second part, and then we used another part of the data is still 2080, right? So we use another 20 data. Third one, we use another 20 data. Fourth one, we use another 20 data. And then we calculate the accuracy, take the average of the accuracy so that we can have a more trustable accuracy for the machine learning. So here will be a better graphics to summarize what is the meaning of the cost validation. So it's a 5-fold cost validation. And then in each one, we take different parts of the 20% of data and then calculate the accuracy. Finally, we will have a average the accuracy of this machine learning model. So it's more, I would say that is you can trust more. Yeah. Application of the classification model. So there are lots of different applications. For example, we have discussed the email. So we use your human expert, right? Human input. So you say, hey, this one is the spam email. This one is the junk email. You click the button, click the button, click the button, and then the Google or a different kind of the email provider. So they will analyze the information of the email, including the length, including the domain that they have sent. For example, is sent from a shop, etc. And also, is there how many cells? Most likely, is how many cells, the keywords of cells inside the email. So they use this kind of attribute x1, x2, x3, put it, and then output whether it's a spam or is a junk email or not. So it's a binary. Why? Yes or no, junk email or not junk email. So put it into this kind of settings and do it. So this is one of the classification. Image classification, cast, dots, etc. That we will we will teach and then we will do it in our face-to-face exercise. So don't worry, we'll go into it. And then to understand the segmentation of the video, segmentation of the image, the understanding our video, the context, what is the information, what is the environment of this conversation. So that is the segment analyze. Website, traffic websites. So where is the cake and then whether this interaction is a true user input, is not done by the machine, it's not done by the robot. So that is one of the analyze. Because at the very at I would say that in 90 something or year 2000, so Google, so they use the user cake or linkage, the website to another website is one of the key reference to recommend in the search engine. So at that time, there are lots of robot that will create some junk website traffic, and then this kind of machine learning algorithm can help to find out whether this one is created by robot, this one is not created by the true user, and then they will filter out this kind of information. Social media, yeah, we can identify what is the information, correct information or suitable information that can be pushed to the user. For example, your in your IG or in your Facebook or in other TikTok maybe. So what is the correct video or correct advertisement that we should push to your front page, push to your social media? That is also one of the application of the classification. Video recommendation, YouTube, Netflix. So this kind of the why my front page and then your front page it will be different. It's also about the machine learning. It's also about the classification problem.